My dear students of Bsc second year, I am Dr. Rohit Parsai, Associate Professor of Mathematics in Engineering Science Humanity Department at Chamitabi Group of Institution Indore. I wish to teach you lecture 6 on Mathematics 3 Unit 2 or Module 2. The solution of simultaneous linear algebraic equations by Gauss-Seidel method is another one in most and the most useful iterative technique is with examples. First of all, we understand the method. First of all, this is the modification of Jacobi method. Let us consider the system of equation a1 of x1, x, b1 of y, c1 of z equal to d1. That is all unknown terms left side and known values on the right hand side. Then if a1, b2, c2 are large as compared to the other coefficient, solve the above system for x, y, z respectively, as we have the step number 1 in our previous method. So then the system equation can be written as, from first one having the coefficient of x is large, you obtain x. From second one, coefficient of y to be large as b2, and from third one you are having the coefficient of z to be large as c3, so that you write find z. Now let us start with the initial approximation x0 y0 for the values of x y z respectively, which may each be to be taken as 0. So now substituting y equal to y0 and z equal to z0, because for finding the x you require y and z, you give y0 and z0 on the right hand side of the first equation of the first approximation are given by x1 equal to 1 upon a1 of d1 minus b1 of y0 minus c1 of z0. Now the correction in this for finding the y is as follows. Since in this for finding the value of y, x is involving, now instead of using x0 you are using this update value of x as x1 and z keeping as it is z0. That is y1 equal to 1 upon b2 of d2 minus a2 of x1 minus c2 of z0. Next, putting x equal to x1 and y equal to y1 in the third one equation of 2, we obtain z1 as d3 minus a3 of x1 minus b3 of y1, so that your modification is start maximally from first iteration. So and so on, that is and so on, as a new approximation for an unknown is found, it is immediately used in the next step. So this process of iteration is repeated till the values of x, y, z are obtained to be of desired degree of accuracy. As a note, we can note down, since the most recent approximation of the unknown are used while proceeding to the next step, the convergence is in the Gauss-Seidel method is twice as fast as in the Gauss-Jacobi method. So Gauss-Jacobi method and the Gauss-Seidel methods converge for any choice of the initial approximation if in each equation of the system the absolute value of the largest coefficient is almost equal to, or in at least one equation greater than the sum of the absolute values of all the remaining coefficient. Let we come to the example on this technique here. So again the pattern is same. You write down all the unknown terms in the left side and known value on the right hand side of these all three equation of the equation that we called by 1. Now then the system of equation can be written as, since first equation में x का लार्ज है, सेकंड में y का लार्ज है, थर्ड में z का लार्ज है, इसलिए हम इक्वेशन से x y z रिस्पेक्टिवली वैल्यूज निकालेंगे. पहले से हमने जो निकाला उसको फर्स्ट वन दिया, सेकंड से हमने y की वैल्यू निकाला उसको सेकंड वन कहा, थर्ड से हमने z की वैल्यू निकाली उसको ये कहा. अब हम पहले वाले से x का मान निकालेंगे तो y और z की वैल्यू 0 रखेंगे. फॉर द फर्स्ट अप्रॉक्सिमेशन substituting y equal to y0 equal to 0, z equal to z0 equal to 0 for value of y and z respectively in 1, you will get x1 is 1 upon 20 of 17 minus 0 into 2 into 0 is 0.8500. Substituting x equal to x1 and z equal to z0 for the finding the update value of x y as y1. In second one, as that is y1 equal to 1 upon 20 or minus 18 minus 3 of x1 plus z0 equal to minus of 1.0275. Now substituting the x equal to x1 and y equal to y1 for as you obtained recently from the third one equation, so that you get z1 we called as z1 is equal to 1 upon 20 of 25 minus 2 into x1 of 3y1 equal to 1.0109. From the second approximation as the iterations, substituting y equal to y1, z equal to j1 for the values of yz. Similarly, you can proceed for kind of getting the value of second time, so you denote by x2 and then you proceed for finding the value of y as y2. Then for finding the value of z as z2, you put x2 and y2 as you have been modified. The value is 0.99 of this. For the third approximation or third time when you are going to use, so फर्स्ट यू ऑब्टेन एक्स के लिए y और z रिक्वायर्ड होगा, तो y2 और z2 आपका मॉडिफाइड हो चुका है, वो वैल्यू आप लोग यहाँ यूज़ करेंगे तो ये वैल्यू हो जाएगी आपकी 1.00. काफ़ी एक्यूरेट आने लगी है वैल्यूज़. इसी तरह से y की वैल्यू निकालेंगे, y3 आएगी -1.000. दैन इसके बाद z की वैल्यू निकालेंगे, z3 ये भी 1 ऑफ दिस आ गई है. नाउ वी कैन सी दैट from the values of second and third approximation being practically the same, now we can stop. The solution is x equal to 1, y equal to -1 and z equal to 1. Therefore we see that the convergence is quite fast in Gauss-Seidel method as compared to the Gauss-Jacobi method. Thank you very much.